All right, I'm going to make this video today just because I wanted to show off the bike. This is a fully electric recumbent motorcycle that I built. Fully custom in the sense that this is basically the only part that we reused off the original motorcycle. This front end is off of a Suzuki GZ 250. Same with the wheel, just had to change out that bearing there. Changed out the headlight, new fairing, turn signals. Other than that, that's all that was original on the bike. From here back, fully custom frame made out of 1.5 by 3-inch tube, fully custom battery box, all made of solid aluminum with a stainless steel support bracket that connects it to the frame. Now, talking about the box itself, inside there are 210 lithium iron phosphate cells that produce 96 volts and maybe about 400 amps, something like that. It's about 105 amp hour battery pack here. So that'll give you a range of probably about 100 miles. Don't know, haven't really tested it too much yet. But furthest I've gone is about 40 miles, and that brought it to about 60%. Anyway, here we got the DC to DC converter that converts the 96 to 12 volts, and that runs all the lights and the contactor as well as the front display. So moving back here, we got the steering system. This is a steering column bearing that I designed, or bearing system, made of some taper roller thrust bearings and then just a normal thrust bearing underneath. Turns pretty easy. Well, not now because I'm not sitting on it, but it turns well. I'll show. Well, it'd help if I unlock it. Very easy to turn. 2 tie rod ends connected to the front. That's how that works. Pretty simple, pretty cool. Then here we got the on button. This is the 96 volt on button that also turns on the contactor when this switch is on. This switch is connected to the DC to DC converter, runs the contactor underneath of the seat that runs off 12 volts. This is the BMS. This balances all of the charges and the batteries on the charge and discharge, and will shut off the power if one of the cells gets too low. Then you got your digital readout here, which will show your charge percentage and the temperature. And yeah, this is all wrong right now. I've been having problems with the BMS. Probably going to have to change that out. I don't know what's wrong with it really, but it's just showing all kinds of wrong voltages. It's supposed to be about 102 volts fully charged. The 96 volts is its nominal voltage, by the way. Anyway, that's your display there. Then you got a little charger here. 2 USB-C, USB-A, and then this is where you actually charge the bike itself. All right, in moving further back, we got the controller box here, controller, contactor, all mounted underneath. We got the full seat. Here is the rear seat foot pegs and the swing arm mount. It's all in line. It's all connected to the same thing. This is a 3-phase BLDC controller that powers the 24,000 watt wheel hub motor. This thing's pretty fast. It can go probably about 100 miles an hour. Top speed, I don't know. Haven't brought it that fast, but rear brake, fender, yeah, that's pretty much it as far as the whole bike is concerned. But yeah, all this is custom made, completely custom rear swing arm. Used the template off that old GZ 250, kind of just to get an idea of what to do here, how to make a swing arm. This one's a little bit bigger than that original one, needed to support the heavier wheel. But yeah, that's about it. All right, I'm going to get into an actual ride of this thing now. Let's see. Got 100% charge. Good to go. Yeah, during this part I was basically just yapping about the bike, but for some reason I didn't think that the audio quality would be garbage because I'm talking through the helmet. That somehow slipped my mind, but anyway, I'll spare you all of that. Just do this B-roll kind of thing right now, up until the rest of the video starts. 210 lithium iron phosphate cells. 90. All right. Alright, that's about all the footage I got. My card ran out of memory, so thanks for watching.